So number 8 on your assignment reads this. Eamon, I guess that's his name. Eamon coaches a hockey team of 18 players. He plans to buy new practice jerseys and hockey sticks for the team. The supplier sells practice jerseys for $50 and hockey sticks for $85 each. Eamon can spend no more than $3,000 in total. He wants to know how many jerseys and sticks he could buy. Okay? So here's a classic situation where we have an inequality. We have some restraints, right? We know sort of what the limits are. We know what the values are for the two things that we're talking about, and we can create some kind of inequality to generate some answers here. So the question guides you through this. It says write a linear inequality to represent the situation. So a linear inequality. So we've got two variables. Let's define the variables here first. So let's say that jerseys are going to be J. Okay, and sticks, let's make those S. And so here's the money total, and here's the price for each. Okay, so we've got $50 for each jersey. So I would suggest that we talk about dollars here. $50 for each jersey. That's going to be the cost of 50 jerseys, or $50 for each jersey, plus $85 for each stick. Okay, and he wants to spend no more than $3,000. So he can spend $3,000 but no more. So this is going to be, so this cost right here, is it going to be greater than or equal to or less than or equal to 3,000? What do you think? Right, he wants to spend less than, right? So he can go less than or equal to $3,000. So here's A. Does that make sense? Does that look good to you guys? So that's the linear inequality to represent the situation. All right. Use your inequality to model the situation graphically. All right. So let's draw a graph. We can totally do that. So I'm going to just. Now we're not gonna buy a negative amount of jerseys or sticks, right? So we can kind of just do a graph that's got positive x and positive y. And you can, so let's say that jerseys are down here and sticks are up here, okay? Now you can isolate for, in this case, s, which would be like the y, but you don't have to, right? You could just find the intercept straight from here. So we did y equals mx plus b for some of our situations. You don't have to. You can go right to here, and this is what I would suggest. So the x is going to be the j, the y is going to be the s. Make your little table of values here, and then put in a 0 for the j, and find out what happens to the s. Okay? So if we put in 0 for j, that means that this term is gone, right? And s is going to be 3,000 divided by 85. Right? Does that make sense? So what's 3,000 divided by 85? That's going to be 35.294. 35.294. Okay, so we'll just write that exactly down there because we're going to draw this line exactly. Okay, so that's going to be our intercept over here, 35, and we can put that on there. So now if we do the same thing for the other one, see, this is how easy the whole intercept thing becomes. So if s is now 0, that means this term is gone, and I have 3,000 divided by 50. What's that going to be? 50 times what gives us 3,000? 50 times 60? Okay, so that's 30 plus the 2 zeros, 3,000. That's right. Okay, so we've got 60 and 0. So this is 60 exactly, this is 35, and I guess we're talking about the numbers of them, whatever. 35.294, let's just leave the whole thing there. All right, so is this going to be a solid line or a dashed line? Or is it going to be something else? Like we're talking about what? We're talking about, can we buy a fraction of a jersey or a fraction of a stick? So actually, x is an element of integers, or even whole numbers really, because we can't go negative, but this is fine. And y is an element of integers too, so in order to graph we've got to keep that in mind. Okay? So we can't actually have combinations that, okay. So if that's the case, then the line that connects these two, okay, because it's or equal to, we can still make it a dashed line. And I'm not going to, I'm not going to really be too sticky on dashes and dots. Well, yeah, I guess, but we can't have. It's not every. Okay, let's go back to the text. Let's go back to the text and just see what we should do. Okay, let's go back to the text. It's good. This is a good question. So where's our? Okay, so the integers ones. This is what I'm looking at. See the integers ones over here. So I see what you're saying. It's equal to, but it's not XER YER. So I'm looking at over here. And so really it should be this line where there's only certain number of dots. But like I say, when you're talking about this here, the dots and the dashes, you need to be able to draw something. So I'm okay with, you want to put dots here like this, that's fine. But then you have to find out exactly which dots are whole numbers and which aren't. So at this point, just go ahead with dashed line is fine. Okay? Because it's just integers. Right? It's just integers. So it's not all real numbers here. Okay? So that's a bit tricky, but we'll go dashed or dotted for this line. Okay? All right, so now all we need to do now is shade above or below the line. Right? Do you guys get that? Do you guys still have questions there or no? I know it says or equal to, so you think that's a solid line, but that's only when it's XER, YER. So if it's integers, let's just do a dashed or dotted line. Okay? Dashed probably be best. And if you did a solid line because of this right here, I probably wouldn't mark you wrong at this point. But you just have to be careful that you know the difference between integers and real numbers. Okay? Does that make sense? Is there any other questions you guys have, or we good so far? Okay, so we have to shade above or below the region. Which one do you think we're going to do? It's a less than, so you think maybe underneath, right? Okay. All right, so obviously if we bought one jersey and one stick, that would be less than 3,000, right? So one jersey and one stick. So it's going to be in here, and we're not going to go negative, so you're going to do this. Now, we actually can't shade the region completely. Why? Again, because it's integers. So we have to kind of do dots, and the dots are going to be on the whole number spots. So if you have graph paper, this is going to be a little bit easier. If you don't, just kind of do the dots like this for now, okay? So it's going to be dotted. The whole point is we have to make sure that it's dotted. So here's my dots, okay? It's dotted because we're buying whole jerseys and whole sticks. We're not buying, so you can't actually order 5.37 jerseys and just pay for 0.37 of a jersey. You know what I mean? So in here it's inherent that the solutions have to be whole numbers and have to be positive because you can't buy negative number of jerseys, right? I'm going to buy -5 jerseys. Can you send that check in the mail to me, please? Right? Because then he would owe you money. So you can't do that. So that's why it's going to be dotted. Make sense?
Yeah.
Okay, so that's B. Got that. Determine a reasonable solution to meet the needs of the team and provide your reasoning. Okay, so now we have to decide which one of these dots are going to be a reasonable solution. Okay, so obviously 1 and 1 is not going to be a reasonable solution. If you've got a team of 18 players, you don't want to buy one jersey and one stick and have everybody else have no sticks and no jerseys, right? So you want to try and outfit everybody, I think, right? So you want to try and at least have 18 of each. I think that would be the first thing that, according to this situation, you'd want to do. So are there any points where we can have more than 18 of each? And again, you're probably also going to want those numbers to be fairly close to each other, right? So that we have like complete sets, or we have a jersey and a stick for a player. If you buy a whole bunch of sticks but only half the number of jerseys, it's like, well, actually that's not a bad idea. I played junior hockey.
It gets a little bit more easy.
And I went through about 80 sticks one year when I was playing junior hockey. Yeah, good thing I didn't have to pay for them. But seriously, it was like, yeah, it turned out to be a stick a game because you're talking about games and practices, and they weren't made real well. Anyways, lots of sticks, bundles and bundles of them. Okay, so double the amount of sticks actually is not a bad idea, but okay, so think through it. So someone give me a possible solution here. What's a possible solution? We want to spend also pretty close to the budget, right? Pretty close to the budget. So what's a point that's going to be either way up here, okay, so more sticks than jerseys, or somewhere around here where they're even, but close to this line? So anybody got an idea? What would be a good combination of jerseys and sticks? Sorry, louder? 20 and 15? Did you say? Is that what you said? Okay, what's another guess? I just want to see. 20 and 20? Okay, what's your guess?
Something within the solution region.
It has to be in the solution
near
region.
The middle of the line.
Okay, so you're talking about a point somewhere around here.
Like a point that would be like 1818.
Okay, so 2020 I think was mentioned. So is that part of the solution set here? Is it? Okay, so if you did your little check, that should be underneath here. And that would be a stick and a jersey for each player of the team, assuming they don't break a whole bunch of sticks. Okay? So if we went something up here, what would be a decision for up here? So is there anything like 18? Let's get 18 jerseys. How many sticks can we get if we just have 18 jerseys? So if we had 18, how many whole sticks could we get? 24? 18 and 24? Okay. So you might think, okay, and I'll trust you that you're checking that. I'm not going to check it right now. But you might say, well, we've got 18 players. Let's just get 18 jerseys, and let's get some more sticks because some of them are going to break. Okay, so there's lots of different reasoning. But you say, well, what happens if someone forgets their jersey, or if we call somebody up, or whatever, right? So yeah, so 2020, 1824, something like that. Does everyone understand the thought process in this question? Right? Okay. So either one of those answers would be great. That they're under the budget, they're close to it, and there's reasoning for the numbers. Okay.
Yeah, there we go. It's good. Good. We did this last year. Thank you. Yeah. No. Just you. Why don't we give you